At this point, we've estimated proportions and we've estimated averages. Now let's turn our attention to estimating variances or standard deviations. Now we're going to do this in the exact same way. We're going to center a distribution around our sample value, and then we're going to construct whatever probability we want to in the middle. So let's see, humans have phased out the element lead from our daily lives after a study that shows its impact on our IQ level. So the study was done with 22 individuals who measured medium exposure, finds a standard deviation of their sample of 22 people of 14.293 points. Let's construct a 95% confidence interval around the true population standard deviation. So we have a distribution, and make sure to really emphasize that this is no longer a symmetric distribution. This comes from a chi-square distribution. We're going to center it at our measured variance, what was our measured variance? Our sample shows a standard deviation of 14.293. So that means our variance is the square of that 14.293. Our variance is 204.2898 points squared. All right, so we're going to center our curve there. And how far do we need to move to collect how much probability? We want a 95% confidence interval. So there's 95 there, meaning that there's 2.5 in that tail, and there's 2.5% in that tail. Now, unlike proportions and averages, we can't move symmetrically because this is a non-symmetric curve. So we have to find each endpoint separately. And the equation is the variance of the population. So the true variance is somewhere between n-1 times the variance of your sample divided by a chi-square left value and n-1 times the variance of your sample divided by a chi-square right value. So these chi-square values, they're just like t-scores or z-scores. We're going to find them using a chart. Let's go through this. So the variance is somewhere between what's n-1. So our study had 22 individuals in it. So our degrees of freedom n-1 is 21. All right, what's the variance of our sample? We already figured that out because it was given to us as a standard deviation. The variance of our sample was 204.2898. All right. Now, what about the chi-square right value? Let's look at our picture. So if we were to draw an asymmetric chi-square distribution with the same setup, you have 95% there in the middle, 2.5 in each tail. So that value right there, oh, I'm sorry, we're starting with chi-square right. The critical value on the right-hand side of this distribution, let's see how to find that. So again, not using z-scores because this is not a proportion. We are not using t-scores because this is not an average. We need to find chi-square distributions. And notice how these values are given to us. Areas to the right of critical values. So if we go back to our picture and we're looking for this value right here, the chi-square right value, there's 2.5% of the area to the right of that. So let's go down our table in our degrees of freedom. So we had 22 individuals, n-1 was 21. And how much area is to the right of that critical value? It's 2.5. So we're looking at this column. So the chi-square right value is 35.479. So 35.479. All right, what about the chi-square left value? How much area is to the right of that? This 95 plus this 2.5 gives us 97.5% of the area. So again, looking at the same degrees of freedom, which column are we going to choose? The one with 97.5% of the area to the left, sorry, to the right. The chi-square left value is 10.283. Okay, so back to our interval. The chi-square right value is 35.479. The chi-square left value was 10.283. If you run through the algebra, you find a lower bound for your population variance as 120.92 and an upper bound of 417.20. So this is a bound for our variance. It's measured in points squared, IQ points squared. Is that what we wanted? We wanted a 95% confidence interval around the true population standard deviation. So I can easily get my standard deviation by square rooting. The population standard deviation is going to be trapped between 10.99 roughly and 20.43. So we're 95% sure that the true population standard deviation for IQ points is between 10.99 and 20.43 points.